Hi everyone, my name is Iswarya. I work as a senior data and applied scientist at Microsoft. In today's reactor session, we're going to learn how to integrate the capabilities of R into Microsoft Power BI. The dataset I'll be using is lyrics from the musical Hamilton. We're going to be learning how to make some cool visualizations using a simple flat file. Let's get started. Okay, so the agenda for today is first some logistics on how to get set up, download all the necessary tools, and learn how to import the data set into Power BI. Then we're going to do some basic exploratory analysis using some pre-built visualizations already available. And then we're going to learn how to integrate R within Power BI to help us do more in-depth analysis using the same data set. I have two different use cases that I'm going to demo. First, we'll take a deeper look at the lyrics of the musical itself and perform some language processing and n-gram modeling to build our own lyric generator. And then the finale is the graph applications. How can we model the characters as a social network? I will be switching between the presentation deck and live demo. So at any point, if you can't hear me or see the right screen, please let us know in the Q&A and Firas can step in to make sure you're all seeing the right screen. So introduction. So what is Power BI? So Power BI is a data visualization service from Microsoft. Its primary use case is business intelligence and analytics. It provides a simple drag and drop interface for users to easily create their own dashboards and interactive reports. Power BI offers support for many data sources, including SQL Server, Oracle, Azure Data Lake, Cosmos DB, Databricks, Snowflake, as well as native support for Excel and CSV and JSON. Today, the file that we're going to be looking at is a simple CSV. Power BI Desktop is just a client version that's used to actually create those visuals. And what is R? R is a programming language for statistical computing and modeling, used a lot in machine learning and statistical analysis. So some prereqs. What you want to do is you want to make sure to download the Power BI Desktop client. Make sure you have the latest version of R downloaded on your system. Enable R visuals in Power BI. So now if you have R downloaded, this is going to be done automatically, but I have linked a way to make sure you're referencing the right directory in Power BI. And then IDE for R, I like RStudio. This is just optional. Now for Hamilton, that's again, not a deal breaker. I'm sure like a lot of you are here because you are intrigued by the prospect of doing data analysis using Hamilton. Okay. The first thing we're going to learn is how to import the Hamilton dataset into Power BI. The hardest part of any data science project is getting access to the data itself, as well as transforming it into a usable form. Fortunately, that difficult bit of wrangling has already been done for me. So I have a nice clean CSV of Hamilton lyrics that someone has uploaded on Kaggle, and I can just download it directly from this link. Before we move into Power BI, let's just take a moment to go over this data set. So there's three columns, a title, speaker, and lines. So the title refers to the song, the speaker is who is singing it, and the line is the line of the lyric itself. So there's a record in the CSV for each line of lyric sung by each character for each song. Going back to Power BI, you want to open the Power BI desktop that you've just downloaded, click on Get Data, click on CSV, and then select the file that we just downloaded. It's the ham_lyrics.csv. This is what the data set looks like after loading into Power BI. However, I noticed that there is a small issue. You see that the column headers are showing up as part of the data set itself, and the columns are named column 1, 2, 3. We don't want that. So what I'm doing is in the query view, there's this nifty function available, use first row as headers. I click on that, and this is what the before and after look like. The title, speaker, and lines have been promoted to the column headers themselves. All right, so let's jump right into a demo. So this is Power BI. As you can see, I've already imported my ham_lyrics data set into Power BI. So the first thing I'm going to do is I'm going to build a bar chart. So I'm going to click on bar chart, just increase it so you can all see it. I'm going to click on lines and drag and drop it into the values, and then click on speaker into the axis. So what am I doing here? I'm looking at the number of lines spoken by each of the characters. Let me increase the size just a little bit. So you can see, and to nobody's surprise, Hamilton, the character after whom the musical was named, has the highest lines by far. I can also change the orientation into a column chart. So I just click on column chart and it immediately changes the kind of chart that's showing up. I can play around with some other visuals, including a tree map. This just shows the relative representation of each of the characters. Let's go back to the bar chart. Another thing I can do is, so on the axis, instead of the speaker, I can drag and drop title. Now what this shows is number of lines by each of the songs instead of the characters. Just another way to explore our data and look at the different dimensions. All right, the next thing I'm going to show is a nifty, handy visual that's already in Power BI called a decomposition tree. So I have my data set. I'm just going to click on this decomposition tree. I'm going to, so you can see that it already says analyze count of lines and explain by title. Let me drag and drop speaker, and I will show you in a minute what this does. So I'm going to do the same thing. So it increase the size just a little bit. So I'm going to click on count of lines and say high value. Click on Hamilton and say high value. Let me do this. So immediately with 2 clicks, you can see the value behind this chart. So instead of the bar and column charts that are static and show just one metric and one dimension, I am now able to slice and dice by both title and speaker. So what that means is I can look at number of lines by song, and within that song, I can look at who sang the most number of lines or the least number of lines. An example would be if you're a Hamilton fan, you already know who sings the song Satisfied or who is the main singer. So I can just go click and verify my hypothesis. I can click on this one. And I can see, and I can see what are the lines that each of the characters are singing themselves. So you can just scroll. I'm going to show you one last example. Look at the speaker, look at the lines. And there's ways to play around. If you want to reverse the pivot, if you want to look at the speaker first and then the title, so you can do the reverse. So you can look at Hamilton, and then you can look at which song Hamilton has the most lines in. So it turns out it's in my shot. Pretty useful visual in my opinion. Now let's go back to the demo. Right, so the decom tree that we saw, again, was a drag and drop, easy to create visual. Here's some applications of where you can use decom trees. It can be used in things like root cause analysis or analyze and aggregate measure across multiple dimensions. An example of root cause analysis could be maybe your business is seeing increased customer support calls and you want to do a deep dive into where it's coming from. So you could pivot by category of issues and the vertical of customers that are reporting certain issues. You could look at sales that are coming across geo or a subsidiary or a particular salesperson. You could explore housing prices by city and neighborhood, or COVID stats by county, city, ethnicity, and so on. Anywhere where you want to visualize data across multiple dimensions, this is a pretty handy visual. And the example that I demoed was the high value. I wanted to look at the characters speaking the most lines. You can go the other way and you can look at negative values. You can look at low values as well. Going back to our data set. So here's the core of the presentation. How do you run R in Power BI? Now, as I mentioned before, the prereq is you want to make sure that R is already installed on your system, the latest version of R, and you have Power BI Desktop. Now, to create the R visual in Power BI Desktop itself, just like you click on bar chart or column chart or decom tree, you click on the R visual. And then we click on enable script visuals as a pop-up that shows up. And then that's it. We get ready to write some R code in the script editor. So the script editor shows, and any code that you write here and any plot that you generate using R programming language is going to show up on Power BI. So the example that I was talking about in the agenda, the first example is we're going to use R to do some n-grams modeling. But first, what are n-grams? This is their technical definition. N-gram is a contiguous sequence of n words from a given sample of text or speech. That's a lot of words to say. Phrase. N-grams are just phrases that you extract from a text document. So in our corpus, and again, corpus is a fancy word for a text document. Our corpus is ham_lyrics.csv. And n-gram, an example could be of a 1 gram is Alexander. Alexander Hamilton is a 2 gram. My name is Alexander. It's a 4 gram. My name is Alexander Hamilton. It's a 5 gram. You can think of n-grams as features, and n-gram models are machine learning applications that make use of these features. So n-gram models are statistical Markov chain models built by analyzing the n-grams that we extracted from a text. So it can be used to predict the next few words with different probabilities. An example could be the autofill function on your phone. So say if you type have a good, maybe the next 3 words that come up are have a good day, have a good morning, have a good pancake. An example could be if our corpus or if our n-grams was built on the Hamilton data set, if you type in I'm not throwing away the model might return shot as the next word with the highest probability, or it could be ball or trash. So there's a lot of advanced use cases for n-gram modeling, such as Twitter bots, news and document classification, natural language processing, speech recognition, language translation, or even autofill, as I mentioned. What we are going to do is a very simple, basic use case where we're going to extract n-grams from the Hamilton data set, and we're going to use something called a babbler to generate our own custom lyrics. Let's get into it. So this is the demo. And by the way, all of the code that I'm showing, I've shared on my GitHub. So at any point, you can go and take a look here. The key functions that I'm using are also highlighted here. Let's go into our demo. So this is again my Power BI. And this is the R visual that I've generated. So this is not this is a custom R visual. This is not a pre-built Power BI visual, as you can see. Now, what is this doing? Another cool thing that you can do within Power BI is you can edit the same script in the external IDE. So my preferred IDE is RStudio. Let's go over the code a little bit to see what it's doing. So I have my data set. which is Hamilton lyrics. So you can click on the data set and view that it's the same lyrics. It's the same CSV that we just downloaded from Kaggle. Then I'm referencing a couple of libraries. What I'm doing is some data cleansing. So I'm making sure I'm combining the entirety of all of the lyrics, the lines into one string variable. And then comes the core of this code where I'm using the ngram function. So here I'm using 5. So I'm trying to generate 5 grams. I'm doing a little bit of data cleansing here. So let me just show this. You can see the plot. I'm going to zoom out the plot just a little bit so you can see it clearly. So this is a list of 5 grams. So you can say that not throwing away my shot is a 5 gram that's generated. And what this chart is also doing is the frequency with which this 5 gram appears in the text. That means not throwing away my shot is apparently showing up at least 8 times in this text. Let me show another example. I'm going to change the number 5 to 7. I'm going to run the same code. Same code, like it's getting the ngram and it's just plotting the text of the ngram. So what this is doing is it's generating 7 grams. So to the bride 2. So, these are 7-word phrases. One last example. Maybe I want to do let's say an 8 gram. So this is again an 8 gram with an additional word. So you can see like the higher the number of n is, you get a little bit of lesser frequency because like these are it is trying to extract longer and longer phrases within the document. Okay. So let's go back to our PowerBI. So this is just simple statistical analysis. I just want to look at the n-grams or themes across the text. Now we can have some fun. We can use the function babel to generate our own custom lyrics. So now what is babel? Babel is a simple Markov chain process that takes as its input n-grams and it creates it, or it tries to impersonate text in the style of the text that it just read. So what that means is that this is not a true Hamilton lyric. This is something that I have generated based on the Hamilton lyrics that we just read. So every time I run this, it's going to generate a random text. Not quite random, it's going to generate a lyric in the style of Hamilton. Immediately you can see the application, you can use it for Twitter bots, or you can use it to write your own, Shakespeare plays if you scrape all the text of Shakespeare in place. Let's also take a look at this code real quick. So the first part of the code is pretty much the same. I'm scraping the data set and I'm generating the n-grams. And then I use the babel function, and here's where I need to specify 2 inputs. One is the set of n-grams that I generated. So my ng is the n-gram I generated. And then I need to generate I need to specify the number of words I want to create in the custom lyric. So this can be better explained with an example. So this is a 100-word n-gram generated from the Hamilton text. Now I can change this to 25. And it generates a shorter lyric. You can go up to, let's say, 250. And it's going to generate something longer. So let's say you want to, this is useful if you want to do something like Twitter, where you have like an actual word limit. So this is what it looks like. Let's go back to our PPT. Okay, so we saw an example where we analyzed the lyrics. Now I want to take a closer look at the characters and the relationships between them. I'm going to show you how you can use the powerful igraph library within R to generate network plots. So let's take a quick look again at our original data set. As I mentioned, ham_lyrics has one record per song, per speaker, per line. This data set, unfortunately, cannot be used as is for our social network plot. So we're going to do some data wrangling, and we're going to be pivoting it into a data set that is more conducive towards graphing. All right, so I'm going to take a second for you to digest this data set. So this is the original data set that we downloaded. So it's got one record per song, per speaker, per line. And here's a transform data set that I have done. And what this has is three columns: speaker X, speaker Y, and weight. So for each unique pair of speakers, the weight represents the number of songs that feature both speaker X and speaker Y. This is a proxy of the relationship between the speakers. You know, how closely do they interact? How often do they come together in the same song? This is and this is a classic example to represent anything for graphing. You usually need a source, a destination, and some kind of a weight. So that's what I've done. So the actual code behind the transformation is out of scope for this presentation. I have used dplyr and a bunch of different joins and summaries, but I have shared it in my GitHub if you want to take a deeper look as a post read. So for all intents and purposes, though, treat the transformed data set as a cleaned up data set in its own right. And you can just download it as you did with the ham_lyrics CSV and start pivoting in Power BI. Okay, so before I go into the demo itself, I want to do a quick refresher of graph theory concepts. All right, so a node and vertex both mean the same thing, by the way. So what is a node? In this graph, Hamilton, Eliza, Washington, Madison, all of these are nodes. What is an edge? An edge is simply the line that connects two nodes. What is the edge weight? Edge weight is the weight column from our transform data set. Remember the number of songs in which each pair of speakers appear together. So what this represents is thicker the line, stronger the relationship between the nodes. So immediately you can see, okay, so Hamilton and Burr have a pretty strong relationship. They appear together in a lot of songs. So do Hamilton and Eliza. Hamilton and Lee, not so much. So that's what edge weight is. I also want to go over a couple of related graph theory concepts. These are applications widely used in things like PageRank and social network analysis. So the concept of degree centrality. So what is degree centrality? It's the number of edges that are connected to the node. So an example is for Lee, it would be 2, you know, see like 2 different edges. Eigencentrality, it's a little bit more complex. It is a measure of how well connected a node is. So how many links their connections have, and so on through the network. What that means is it identifies, eigencentrality identifies nodes with influence over the whole network, not just those that are directly connected to it. And this is a direct application used in things like PageRank, where you know the PageRank of the page that's linking to your page is also important. It's a bit of a recursive concept. So those are some graph theory concepts. And as a fun exercise, I want you to guess which character has the highest degree and eigencentrality. And maybe if you want, you can put it in the Q&A box, just bragging rights. Let's go to the demo. So as you can see, I have my Hamilton speaker relationships file over here, transformed. And then I have my social network. that's getting generated over here. Just like we did before, let's take a look at the code in RStudio. Now, what is this doing? So remember that this data set that I'm reading here is not the ham_lyrics. This is the transform data set, the speaker relationships. So now if I click on data set, it's going to look a little bit different. It's going to, not this one. Yeah, so it's going to look at speaker X, speaker Y, and weight. This is the transform data set. Now I can do a little bit of exploratory analysis of the data set itself. So I can look at histograms, tables. These are not necessary. This is just to show the capabilities of R. I'm doing some data cleaning here. And then I'm creating something called an adjacency matrix. Now, what is an adjacency matrix? So remember the data set that we created. So it's a flat data set. It's got, a relationship between speaker X and speaker Y and weight. So it's got 3 columns. What an adjacency matrix does is it's going to create an n by n matrix of each of those characters. So if we had n characters in the data set, it's going to create an n by n matrix, and it's just going to pivot that weight. It's going to, so you saw here that, the weight between Burr and Hamilton is 21. It's just going to pivot it accordingly. And because it's undirected, that's why you see both those directions. So you see from Hamilton to Burr and Burr to Hamilton. It doesn't matter that it was 21 and 42 here, because all we're looking at is relative weights. Like, what is the relative relationship of Hamilton and Burr versus Eliza and Hamilton? And then I'm creating the graph object. So now this is necessary for us to generate that social network plot that I spoke about. We can explore the graph object a little bit. So I can look at the number of vertices it has. So it says it's got 16 vertices. I can look at the number of edges using the eCount function. And then I can look at the number of, I can just look at what are the vertex names. We know this. And then I can look at the edges, or it says like from to what is the weight. And now come the centrality measures. I hope you had a moment to think about the degree and the eigencentrality. So the degree centrality, Burr actually has the highest degree centrality, it looks like. So Hamilton is connected 13 times or connected to 13 different nodes. Burr is connected to 14 different nodes out of all the 16. And then I can look at eigencentrality, as I mentioned. So now this gives me a lot of variables. I just want the vector. So it says, again, Hamilton has the highest eigencentrality, which means, Hamilton is the influencer of the network almost, even though Burr has a higher degree centrality. So there's a lot of centrality measures. There's closeness, there's betweenness. These are all used heavily in social network analysis like Facebook and Twitter, and even network theory concepts. This is just an example of like how transforming our flat CSV file into a graph object opens these avenues into graph theory for additional analysis. Now the fun part. Let's just plot the graph. So this is my plotted graph. And it's not very pretty. So what I'm going to try to do is I'm going to use some of the additional features within the igraph function, some of the additional things like layout and vertex color. So I'm going to be using something called a star layout with Hamilton as its center. So immediately you can see that it's a much more readable graph. This does look better than the first graph. Back to the first graph. This is what it looked like. And this is what it looks like now. with the star layout. So remember, I'm just using the layout equals layout.star. Not bad, but this graph doesn't show us anything about the relative importance of characters or even the relative relationship between those two characters. So this is where the degree and the edge weight come into play. So what I have here is I'm going to plot the igraph object. And the rest are the same. I'm saying use the graph object's names. I'm using star layout here. And then I'm using edge.width as a direct function of the egraph object's weight. And vertex.label.cex is a representation of the font size of each of these characters. That is direct function that is directly correlated to the degree of the graph itself. Let me run this and it'll make a little bit more sense. So now you can see that all of these look uniform. It's almost as if everybody has the same importance in the graph. Now, if I run this, zoom out a little bit more. This is a lot more intuitive. You can immediately see that, like Hamilton has a high degree, so does Spur. And, like you can see things like Angelica, and you can see the relative relationships between those graphs. So just visually, it makes a lot more intuitive sense. Another fun fact that I always point out is King George is up here all by himself. That's because most of his songs, he's just singing them by himself. He's not with any of the other characters. So that's why you see him not having an edge towards any of the other characters. Just a little bit of a fun trivia if you want to hum the song. Cool. Now, so that's the same code, and it's being generated in PowerBI as well. Now going back to our presentation. So some of the applications. So I spoke a little bit about the applications of specifically of decomp trees, as well as of something like n-grams, including like Twitter and Reddit analysis and generating your own lyrics or generating your own plays. The applications of graph theory are boundless, literally. However, the purpose of this demo was to show that you can use R in Power BI for anything. So anything that R is capable of, you can bring all that power into Power BI. And again, it's not restricted just to R. This is for Python. Power BI has Python integration as well. So things like if you have a chart on Power BI that's just static, it's just showing historic trend data. You can do forecasting with regressions. You can do text analysis, like I showed, classifications, anomaly detection, time series analysis, like ARIMA modeling, network plots, chi-square or z-square test, any kind of statistical modeling or correlation plots, basically. So any kind of R or Python models that can be visualized on the fly, you can do that. So pretty powerful capability in my opinion. And with that said, that's my last slide. I have all the code used in this demo. I've also linked some helpful links and resources for R and for Power BI as well as igraph. And that's my bio. If you want to reach out to me on LinkedIn, if I can answer any questions, I'm more than happy to help. Thank you. Any questions?
Iswarya, sorry to interrupt. I just want to say one thing before we all wrap it up. First of all, I want to thank you for this great workshop, and I want to thank everyone who joined. And I just want to put in the chat in the Q&A now a link to the as a survey link. So if any of you have any sort of feedback of how this event went, we'd really love to hear what you have to say, but you just have to use the code 12302. I'm going to put the link now. And so just let me put it. And one more thing is that everyone here can check this workshop or previously recorded workshops on our YouTube channel. I'm also gonna put the link for it in the Q&A as well. All right, so they're all there. And for everyone, if you haven't joined our Reactor family yet, please, you can check us on our meetup pages or on YouTube or even on Twitter. So again, thanks a lot for joining. And the rest of the time, I think we're gonna wait for your questions. All right, everyone, since there are no questions, I think we're gonna wrap this up. Again, I want to thank everyone for joining, and Iswarya, thanks again for this lovely workshop, and thanks a lot. Everyone have a good day.